Okay, shall we start now?
Yes, sir.
Okay. Okay, see, all of you can observe that on the screen. So I have, okay. So here you can see the Fourier's law of conduction equation is there. So, so generally for single slab, so we write this Fourier's law of conduction as Q is equal to minus Ka into bracket T2 minus T1 divided by L. Okay, this is the general Fourier's law of conduction for single slab it is. Okay, so as you see here minus Ka, right? Minus sign is there. So to convert that, because T2 value is always less compared to T1, so for that purpose, to make it the value of K or the value of Q as positive, so we are rearranging it, right? Q is equal to K into bracket T1 minus T2, right? Otherwise, the bracket value T minus T1 is always negative. So rate of heat transfer Q is equal to K into bracket T1 minus T2 by L. So this is the equation for Fourier's law of conduction for a single slab, right? So as you can see, there is a slab, single slab. It is having a thermal conductivity of K, and it is also having area A, right here. You can see. So Q is the rate of heat transfer. T1 is the temperature at the left face. Then T2 is the temperature at the right face. It is having a thickness of L and having a thermal conductivity of K and a cross section area of A, right? So for this, you can write the equation Q is equal to K into bracket T1 minus T2 divided by L, and the unit is watt here. The next part is heat flux, right? Heat flux is there. So yesterday we discussed this. Again, I want to clarify that part. Q heat flux is usually denoted by small q. So it is the ratio of rate of heat transfer to its area, to its cross section area. It is Q divided by A, right? So as you can see here, the A value is not appearing here in this case, right? A, K into T1 minus T2 by L it is, right? So this Q by A, that we call it as heat flux, and you can observe the unit for this, it is watt per meter square. Watt per meter square, okay? So one more thing here, I want to tell you, this Q is equal to rate of heat transfer is equal to K into bracket T1 minus T2 divided by L, right? This is the equation, Fourier's law of conduction. So the same can be written as like this also, right? Q is equal to T1 minus T2 divided by RTH. RTH is nothing but the resistance offered by the slab. So what is the value of that resistance? It is L by Ka, right? L by Ka, as you can see here. RTH, if I take this Ka here, whatever the K value you are observing here, Ka, so K into T1 minus T2 by L it is, right? So if you rearrange, you will get a T1 minus T2 divided by L divided by K. So I need to take this K at the, that is denominator part, right? So it will become T1 minus T2 divided by L by Ka, right? It will be something like this. So where RTH, thermal resistance offered, is given by L by Ka. So this we call it as thermal resistance. Okay. So this is for single slab, right? This is for whatever we discussed here. So it is for single slab. Okay. Now coming to this Newton's law of heating and cooling for convection. So for convection, as you can see here, so convection is another mode of heat transfer where heat transfer takes place from the solid surface to the medium. Either medium, it may be air or any liquid, right? So as you can see here, there is one plate. Plate temperature is maintained at a TP. TP is the plate temperature, and over which air is blown, right? Air is blown, right? The temperature of the air is T infinity. T infinity, just a notation T infinity. And in order to transfer the heat from plate to air or from air to plate, H parameter is required, that we call it as convective heat transfer coefficient, right? That we call it as convective heat transfer coefficient H. Okay, so for that the expression will be something like this: Q is equal to, so for this is for convection, right? So Q is equal to H into AS into Tp minus T infinity. So here Tp is the temperature of the plate and T infinity is the temperature of the air. Okay, so this holds good when the temperature of the plate is greater than temperature of the air, right? So this holds good because Tp should be greater than temperature of the air. Temperature of the plate should be greater than temperature of the air. Okay. Now there is one more possibility is here, right? So for the same condition, if the temperature of the air is higher than the temperature of the plate, so as we discussed yesterday, so the temperature of the air was higher compared to temperature of the plate at that time. So you have to rearrange it, right? So Q is equal to H into AS into bracket T infinity minus Tp it is. So this is for T infinity. T infinity is nothing but the temperature of the air. It is greater than Tp or temperature of the plate, right? So in first case, what happens? In first case, right, Tp is greater than T infinity, first case. So here, this Tp, the temperature of the plate is higher than the temperature of the air. At that time, heat transfer will take place from the plate to the air, right? This is the case, right, when the Tp is greater than T infinity. Whereas there is another case, if T infinity is greater than Tp, if the air temperature is higher than the plate temperature, at that time heat transfer will take place from the air to the plate, from the air to the plate. Okay, so here one more thing you can observe here, that the AS is there. AS is, we call it as surface area. See, don't get confused here. Yes, surface area, it is surface area. It is not the cross section area. It is the surface area in, to which this air comes in contact with the plate. So that area you have to consider the surface area. It is not the cross section area. Okay. So this is for Newton's law of cooling and heating. Okay. Now there is one more possibility. So okay, second page number 2 now. Now we'll discuss this. So here you can see there is a composite wall, right? There are two plates are there, right? Two plates. It is having a area A1, thermal conductivity K1, and the temperature T1 and T2 are the surface temperature of this first block, right? Similarly, there is another block which is in contact with it. It is having the area E2, and K2 is the thermal conductivity of the second block, and the temperature interface is T2 and T3. T2 and T3. Okay. So here you can see T1 is greater than T3. Right? T1 is greater than T3. So definitely heat transfer will take place from the left to right, from left to right. And also these blocks, right? Block 1 and block 2 is having a thickness of L1 and L2. L1 and L2 will be the thickness of the plate. Okay. So each block here, as you can see, each block is offering certain resistance. So that resistance we are writing in terms of R1 and R2 here, R1 and R2. R1 is the resistance offered by the first block and R2 is the resistance offered by the second block, right? So for this case, you have to write the equation using Fourier's law of conduction. Okay, always remember that the rate of heat transfer, this Q, right? Q is taking place from left to right, from extreme left to extreme right. The heat rate of heat transfer. Okay, and at same time, rate of heat transfer in first block is equal to rate of heat transfer in second block. No doubt there will be certain losses, but we ignore those losses. We consider that जितना भी heat first block को आता है उतना ही heat second block को भी जाता है करके, right? Rate of heat transfer which is entering the first block, heat entering the first block is equal to heat uh, which is what to say, heat entering the first block is equal to heat entering the second block. So there should not be any heat losses. It is one assumption, our assumption, that there is no heat losses will take place. जितना हीट फर्स्ट वॉल को जाता है उतना ही हीट सेकेंड वॉल को भी जाता है. Okay, now come to this part now. Okay, very first, so Q is equal to the very first equation. Q is equal to Q1 is equal to Q2, right? Q is equal to, Q is the rate of heat transfer for the entire system, is equal to, for entire system means including both the walls here. So Q is equal to, Q is the rate of heat transfer throughout the composite wall, is equal to rate of heat transfer through the first wall is equal to rate of heat transfer to the second wall, right? Q is equal to Q1 is equal to Q2 it is. Okay, now you can see here, so Q is equal to rate of heat transfer Q1, Q is equal to, so we can write the general equation, that is Fourier's law of conduction for first wall. So it will be K1 A1 divided by L1 into T1 minus T2. So you can observe the temperature zones also here in this diagram. So T1 is the extreme left temperature, and T2 is the extreme, T2 is the middle intermediate zone, it is T2, and T3 is the extreme right surface, right? Extreme right surface is T3. Okay, so we will write the equation here. This is the first equation Q1, right? So for Q1, what is the general equation? K1 A1 divided by L1 into bracket T1 minus T2. So this is the equation for first block. K1 A1 divided by L1 into bracket T1 minus T2. Okay. So this has to be equal to Q2, right? So the second, coming to this second part now. So K2 A2 by L2 into bracket T2 minus T3. T2 minus T3. So as many number of blocks increases, जैसे जैसे ब्लॉक का इंक्रीज होते जाता है वैसे वैसे उसको एड अप करते जाना है, राइट? So K2 A2 divided by L2 into bracket T2 minus T3. Okay, so this is for, so what we are discussing, this is the rate of heat transfer through individual walls, it is, right? Individual wall. Q1 is given by K1 A1 divided by L1 into bracket T1 minus T2. Now Q2 is given by K2 A2 L2 into bracket T2 minus T3. Okay, so if we consider, so these are the values of Q1 and Q2. Okay, if we consider the rate of heat transfer throughout the wall, throughout the composite wall, right? It is throughout the composite wall. Considering this as a system, right? Entire system, both the walls together, right? So at that time, this Q, the whatever the Q value you are seeing here. So now I'm going to write the equation, right? Q is equal to, right? Q is equal to, so as you can see, T1 minus T3. So extreme temperature zone, T1 minus T3 it is, T2 वहां पे नहीं आएगा, delta T it will be, T1 and T3 will be the delta 3. Okay, delta T it is delta T, T1 minus T3. अगर और एक वॉल है तो उसका और एक टेम्परेचर आता है T4 करके. Alright, we will see that later on. So here Q is equal to what? This is the rate of heat transfer to the entire wall, it is. T1 minus T3 divided by, so resistance offered by the first wall, it is L1 divided by K1 A1. So this is the L1 K1 A1, right? This is the resistance offered by the first block, plus L2 divided by K2 A2. L2 divided by K2 A2. This is the resistance offered by the second block, right? So this is the total resistance offered, right? This is the total heat transfer offered. The heat transfer occurred during the through this composite slab. Okay, so these three equation, whatever you are seeing, one for the entire composite wall and one for block number 1, rate of heat transfer through block number 1, and a rate of heat transfer through the block number 2, right? So these three has to be equal, right? It is given by Q is equal to Q1 is equal to Q2, the very first equation, right? What is this? Q is equal to Q1 is equal to Q2. You remember this. Rate of heat transfer throughout the block is equal to rate of heat transfer in the first block is equal to rate of heat transfer in the second block. So Q1 is the rate of heat transfer in the first block, Q2 is the rate of heat transfer in the second block, and only capital Q is there, no, capital Q. So that is the rate of heat transfer throughout the block, right, throughout the composite wall. Okay, so here this Q we can write, see here, this is for throughout the wall, throughout the composite wall. So this Q is equal to T1 minus T3 divided by L1 divided by K1A1 plus L2 divided by K2A2. So this L1 divided by K1A1 is the resistance R1 and L2 divided by K2A2 is the resistance R2, right? R1 and R2 are the resistance, right? So we can write this as T1 minus T3 divided by thermal resistance of entire wall, right? This RTH thermal resistance is L1 divided by K1A1 plus L2 divided by K2A2. So this is the resistance offered by the entire block to the flow of heat. Okay, now coming to this one more part. Okay, see here. So same I am writing here, Q is equal to, okay, Q is equal to, as you can see here, over here, Q is equal to rate of heat transfer throughout the block is equal to rate of heat transfer through the first block is equal to rate of heat transfer to the second block, right? So this is the general equation. This is the general equation what you are seeing on the screen now. At the top, Q is equal to rate of heat transfer throughout the composite wall. Q is equal to T1 minus T2 divided by L1 K1A1 is equal to T2 minus T3 divided by L2 divided by K2A2. Right? This is the rate of heat transfer. The rate of heat transfer throughout the wall or throughout the each block will remain constant. What this indicates, rate of heat transfer हमेशा एक समान रहता है हर एक ब्लॉक में. Either you consider in individual blocks or you consider it as an entire composite wall. Right? The rate of heat transfer will remain constant. So here Q is equal to T1 minus T2 divided by resistance offered by the first wall. This is equal to T2 minus T3 divided by resistance offered by the second wall. So again, I am writing this Q is equal to Q1 is equal to Q2. Q is equal to Q1 is equal to Q2. Okay. So this is the resistance. This is the, we can say not resistance, we can say rate of heat transfer either from the entire composite wall or either from each first block as well as the rate of heat transfer to the second block. So the rate of heat transfer will remain constant. Okay, now you can see there is one more wall I have right here to, okay, one more wall I have given for three composites. Usually in your exams you will be facing problems related to three composite walls, right? As you can see here, 1, 2 and 3 composite walls are there. As you can see, 3 composite walls are there. It is having a first wall is having a temperature of T1 and T2, thermal conductivity A1 and thermal conductivity K1 and cross section area A1, and the thickness is L1. For the second block, temperature range is T2 and T3. T2 is the higher temperature, T3 is the lower temperature. K2 is the thermal conductivity of the second block and A2 is the cross section area of the second block, and L2 is the thickness of the second block. Similarly, this third okay, third block it is. So third block T3 and T4 are the temperature zone, and K3 is the thermal conductivity of the third block, right? Third block, and A3 is the A3 is the area, cross section area. A3 is the cross section area. Okay. Okay. Now, now we try to form the equation for this, right? We try to form the equation for this composite wall. Okay. समझ में आ रहा है? Are you getting?
Yes, sir.
Hello.
Yes, sir. Yes.
Huh? Getting, no? All of you. Okay. Okay. Now coming to this. So for the entire block, first we will write the equation for the entire block. right? Q is equal to, what is the expression? Q is equal to T1 minus T4. As you can see here, first I will write the expression for this Q, right? The very first equation, right? That is for Q. Q is the rate of heat transfer throughout the composite wall. So what are the extreme temperature zones? T1 and T4 are the extreme temperature zones. Here T1 is there and T4. T1 is the extreme left face and T4 is the extreme right face. Okay. So delta T. So this we call it as delta T, T1 minus T4. Okay. Divided by resistance offered by the each block. So resistance offered by the each block. The first block resistance is given by K1 L1 divided by K1 A1. Right. This is the resistance offered by the first block plus L2 divided by K2 A2. It is the resistance offered by the second block plus L3 divided by K3 A3 is the resistance offered by the third block. Okay. Or I can write this as T1 minus T4 is equal to RTH. So RTH is the thermal resistance offered by the entire three blocks, right? RTH, thermal resistance offered by the wall, composite wall, RTH, it is RTH. Okay. Okay. So here you can see on the diagram, just below the diagram, one R2 and R3 is there. So R1 is the resistance offered by the first block. It is given by R1 and its value is L1 divided by K1A1, right? Then similarly L2 for R2, so that is for the thermal resistance R2 or the resistance offered by the second wall, it is L2 divided by K2A2. And for the third block, that is the resistance offered by the third block is given by L3 divided by K3A3. Okay. So this is the what you are observing here. So this is the expression. This is the expression for entire composite wall. This is for entire composite wall. That is T1 minus T4 divided by R1 plus R2 plus R3. Okay. Now we try to write the equation for each block now. For each block. So Q1 is equal to, as you can see, the temperature zone, that is for first block. Okay, try to go through this. So Q1 is equal to, for the first block it is, right? Q1 is for first block, that is the rate of heat transfer through the first block. So temperature zone for the first block is T1 and T2. So that's why it is T1 minus T2 divided by L1 divided by K1A1, right? So this is the temperature difference. Oh, sorry, this is the thermal resistance offered by the first block, that is T1 minus T2 divided by R1. Similarly, Q2 is equal to, so delta T is what is T2 minus T3 divided by L2 divided by K2A2, right? So it is given by T2 minus T3 divided by R2. R2 is the resistance offered by the second slab. Then similarly for third block Q3 is equal to T3 minus T4 divided by L3 divided by K3A3. So this is equal to T3 minus T4 divided by R3, right? So here these are the individual. So we can say that rate of heat transfer throughout the composite wall. So this Q stands for rate of heat transfer throughout the composite wall is equal to rate of heat transfer through the first block, rate of heat transfer through the second block is equal to rate of heat transfer through the third block, right? Any doubt here? Any doubt? Yes, any doubt? If you are having any doubt, you can ask me. Okay, the same I will show you here. I will try to modify it here. Okay, you can see here. I have written one more here. Okay, one more equation. So till now you have seen this Q is equal to, what is that equation? Q is equal to Q1 is equal to Q2 is equal to Q3, right? Right. Now, while solving the problem, you can make use of any of these two Qs. ये कौन से भी दो Q लेके इक्वेट कर सकते हैं. Either you can equate Q is equal to Q2, or you can equate Q is equal to Q1, or you can equate Q2 is equal to Q3. यहाँ पे कौन से भी दो Q का वैल्यू लेके आप इक्वेट करके अननोन फाइंड आउट कर सकते हैं. Okay, I have written the same here as you can see. So the value of q I have written on the extreme right side here. Okay, this is the T1 minus T4. This is the rate of heat transfer throughout the composite wall. So this is nothing but capital Q, right? This is nothing but capital Q. Okay, now you please analyze this. So rate of heat transfer through the entire wall, right? T1 minus T4 divided by total thermal resistance offered by the composite wall. It is given by. So individually, I have tried to separate it. So T1 minus T2, here you can see T1 minus T2 divided by L1 divided by K1 A1. So this is for the first block, that is Q1. That is the rate of heat transfer through the first block. So this is equal to rate of heat transfer through second block, T2 minus T3 divided by L2 divided by K2 A2, right? This is for the second block. And this is for the third block, T3 minus T4 divided by L3 divided by K3 A3. This is for the third block. So this is equal to the entire system, that is T1 minus T4 divided by R1 plus R2 plus R3, right? So here, so this is how I try to cover up this, how to generate the equation for either it may be a single slab or a composite wall, two composite wall or a three composite wall. If you understand this part, okay, let me clearly listen this part. Okay, if you whatever I have written in these 3 pages, ये 3 पेज में जो भी लिखा हूँ, अगर आप लोगों को ये करेक्ट से समझ आ गया समझो, then you can solve any of the problem that is related to the first module. फर्स्ट मॉड्यूल के कौन से भी प्रॉब्लम थोड़ा सा मॉडिफिकेशन करके, लेकिन फर्स्ट यू हैव टू अंडरस्टैंड दिस, हाउ टू जनरेट द इक्वेशंस फॉर individual slab. Note we have generated with the help of Fourier's law of conduction only. Fourier law of conduction से ही हम लोगों ने एक composite wall के ऊपर हम लोगों ने we have generated the equation, right? So you practice it once or twice. जो भी मैं यहाँ पे लिखा हूँ, you just you rewrite it once or twice. So you can easily understand this, what is Q1, what is Q, what is Q3, what is the equation for entire this entire composite wall. So that is nothing but Q. Q is the equation for entire slab. Q1 is for first block, Q2 is for second block, and Q3 is for third block. And the rate of heat transfer throughout the slab, it will remain constant. Okay. अगर ये कॉन्सेप्ट क्लियरली समझ में आ गया तो you can solve any of the problem that is related to your first module. Okay. Okay, now I will show the same in your data handbook. So this is the data handbook, page number, okay, page number 45 कुछ है. Anyhow, you please एक बार data handbook सबके पास है? All of you have data handbook with you? नहीं है तो प्लीज, आई टोल्ड यू लॉन्ग बैक,
Yes, sir.
15-20 दिन पहले. हाँ, ओके. सो प्लीज डाटा हैंडबुक नहीं है तो डाटा हैंडबुक का अरेंजमेंट कर लो. ओके, अगेन आई एम रिमाइंडिंग यू. ओके, सो सी दिस इज द first, this is the block, as you can see, it is having L as the thickness, T1 and T2 are the temperature zones, T1 and T2, and the rate of heat transfer is taking place from the left to right because T1 is shown at higher point and T2 is shown at lower point. So by this we can consider that rate of heat transfer is taking place from left to right. And you can see this is the cross section area, right? This is the cross section area. A is there, no? So this area you have to consider. Always keep it in mind. This area, ये cross section area है, right? Okay. So this area you have to consider, right? So K is thermal conductivity. K is the thermal conductivity. Okay. Now, as you can see here, on the very at the top of this page, heat flow is given by Q is equal to delta T by delta T overall divided by R. So there is an expression. Heat flow Q is equal to delta T overall divided by R, right? So if in this diagram, what is the value of delta T? Delta T क्या है बोलो? It is T1 minus T2. Delta T is nothing but T1 minus T2. And what is the value of R? The same R value I will show you here, right? So for the first block, okay, for the first block, the value of R is L divided by Ka, as you can see here. R is equal to L divided by Ka. Okay. Is it visible, all of you?
Yes, sir. Yes.
Delta T is what? T1 minus T2 is the delta T, and R is, if you substitute R over there, ये जो Q का इक्वेशन है वहां पे अगर R का वैल्यू देके लिखेंगे तो you will get the same expression what we discussed just now, right? What we discussed just now. So that will be the expression. And then similarly for convection. Now coming to this convection, as you can see here, so there is a plate, right? It is having a surface area A. Tw is the temperature of the wall, and the T infinity is the temperature of the fluid, right? So here the rate of heat transfer Q is equal to delta T divided by R. It is again, right? Okay, if you rearrange that, Q is equal to, right? Q is equal to delta T is what here? Tw minus T infinity. I will consider T temperature of the wall is higher than the temperature of the air. So delta T, what will be the delta T? Delta T will be Tw minus T infinity. Tw minus T infinity. Okay. So Tw minus T infinity. If you substitute over here delta T का वैल्यू यहाँ पे कितना क्या सब्स्टिट्यूट करना है? Tw minus T infinity. And what is the value of R? R value is already given here. 1 divided by HA. This is the resistance offered. Okay. This is for convection, right? Then similarly for radiation. So for radiation, as you can see, there are two plates, and in between plates, in between the plate, it is totally vacuum, right? So first plate where T1 is shown, no, that is the area of the, that is the that is one extreme left surface, and T2 what you are observing, there is one more plate, so that is another plate, right? Second plate. So the space between these two plates is totally vacuum, right? So for this resistance offered, R value, this whatever the value you are seeing here, so that is nothing but the value of R. So thermal resistance offered is given by 1 divided by sigma into A into F into bracket T1 square plus T2 square into bracket T1 plus T2, right? This is for the radiation, black body radiation, right? This is the expression. No doubt the value of heat flow will remain constant. ये जो ऊपर का जो equation दिखाई दे रहा है आपको, heat flow is equal to Q, that is heat flow Q is equal to delta T overall divided by R. So this will remain constant. This will remain constant for either it may be conduction, convection or radiation. अगर कंडक्शन का है तो कंडक्शन का है ये R का वैल्यू ये रिप्लेस करेंगे, R इज इक्वल टू L डिवाइडेड बाय के. अगर कन्वेक्शन है तो R का वैल्यू ये रिप्लेस करेंगे 1 डिवाइडेड बाय HA. अगर रेडिएशन है तो R का वैल्यू इससे रिप्लेस करेंगे, दैट इज 1 डिवाइडेड बाय सिग्मा A F into bracket T1 square plus T2 square into T1 plus T2. Yes. Any doubt here?
No, sir. Understood, sir.
It is clear, no? Okay.
Yes, sir.
Okay. So similarly here certain notations are there. You please go through it. So what are those notation? Delta T is the overall temperature difference. Overall temperature difference. Either it may be in degree Kelvin or degree Celsius. Then R is the thermal resistance. Q is the heat flow. K is the thermal conductivity. A is the area. L is the thickness, right? Then coming to Tw is the wall temperature, T infinity is the fluid temperature, H is the convective heat transfer coefficient, right? And sigma is the Stephens-Boltzmann constant, and its value is 5.67 into 10 raised to minus 8. And F is the shape factor. So later on we'll discuss what is that shape factor and all. You are having one separate chapter, right? Separate chapter for radiation, thermal radiation. Okay. So this is the very first, it is, I think it is page number 42 or 43 in your data handbook. You please go through this. ये हमेशा याद रखो, ये ऊपर का फॉर्मूला कोई हमको रिलेट करना है. हीट फ्लो इज इक्वल टू डेल्टा टी डिवाइडेड बाय आर. अगर कंडक्शन है तो आर का वैल्यू ये लेना है, दिस एल डिवाइडेड बाय के. अगर कन्वेक्शन हो रहा है तो ये वैल्यू लेना है, अगर रेडिएशन हो रहा है तो ये वैल्यू लेना है. ओके. So this is for दिस इज फॉर सिंगल, एक ही है वहां पे, सिंगल सिंगल स्लैब इट इज, राइट। अगर कंपोजिट है तो कैसा करेंगे, राइट। एज यू कैन सी